Hello and welcome back. In front of me I have a whole bunch of stuff because I figured we would build the function generator kit from a previous mailbag. So unlike a lot of other kits that are, I would say, pretty well made, this one a little bit less so, and the reason for that is because here you see R6, R1, R1, R4, etc. And the values are not written on the silk screen. So if you get one without this packing list, you won't really know what the heck's going on. So let's start up here. R1, 1K resistor. And for that, I will bring in my multimeter. I don't even know where to put this. Everything's too cramped. So I have this in ohms. So the kit has 3 of the same resistors and then 2 other ones that are different. So these 3 resistors and these 2. I figure this one's the 1K. I don't know if you can see the color there. I guess it is brown, brown, black, black, brown. But I just remember that the 1K doesn't have any colors in it. Yeah, there we go. 1K. Alright, so we're going to put this in, and that is our... Oh, and I just tore the sheet. Fantastic. So R1, 1K. So let's go find R1 on here. R1. Give it a good bend. Shove this in. And looks like these resistors are the right ones. Sometimes they give you a footprint for a 5th watt or 8th watt resistor, and they give you a 1/4 watt resistor. So there's R1. Let's see here, R2. You can see off to the side. Adjustable resistance. That is one of these pots here. So I'll skip over to the next one. R3, 5, and 6 are 5.1K. And I think, if I'm not mistaken, I think green is 5. So these 3 here that have green in them, those should be, let's see here. I see green, brown, black, brown, brown. And again, I don't know my resistor codes by heart. That is 5.1. So this is for R3, R5, and R6. So let's see. R6. Right there. Have the green to the right. I'm going to turn on my soldering iron too. Green, brown, black, brown, brown. So that would be R3, R5, R6. R3, R5, both over here. And this last one here. Yeah, green, brown, black, brown, brown. And there we go. So 4 resistors in. We only have the 5th one here, so it'll be R4. R4 is supposed to be 330 ohm. I'm going to check it anyways. Making sure not to chuck any of these caps onto the ground. That orange there must mean 3 because it's orange, orange, black, black, brown. So yeah, 330. I'm going to put put this guy in. There we go. It's got 5 resistors in. I don't think there's anything that's the same height as the resistors, so I'm just going to solder these down before we move on. Got a blob of sticky tack there. See if I can center it a little bit more. Just going to make sure all these resistors are sitting flush or pretty flush. I'm going to bend the leads. I don't want to bend them too much. That's good there. That's good there. I know old wisdom states that you shouldn't really stress the leads too much, but in practice I've never found that to be an issue. Got my lead solder here. Of course, if this kit was you know, $100, then maybe I would be a lot kinder to my components, but kit's cheap. These are just passives we're putting in. There's, I think, one active component in this whole thing, which is the microprocessor. But that's in a socket, so you don't even have to worry about soldering too much, or the heat, or the stress. Hopefully this kit works first try too. Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think so. They look pretty flush. I'm gonna trim the leads off. Careful not to ping them across the room. Alright, so those are the lowest components. These are a little off to the side, but that's okay. It's not that big of a deal. There we go. Now we have to choose which components go next. The components are starting to get tall really quickly here, so I'm not exactly sure which one the wisdom would say to do, but I think I'm going to do these caps here. So the caps, unfortunately, are all different. These they look like tantalums or ceramic. I'm not sure. But again, we have to go to our chart for the capacitors because they're all different and they're not marked down here. So C1, electrolytic, we won't worry about that for now. C2, non-polarized, 104. So 104, that is C2. I'm going to set that into C2 up here. Okay, not polarized, don't have to worry too much about the direction, but I am going to solder it in from this side. There we go. I think that's what I'm going to do, solder them in from the front side, touch them up from the back after. Simply because if I flip them around, they're going to fall out unless I bend the leads. Okay, so this piece is not necessary anymore. Let's see, C3, C4 is electrolytics, both the same. C5, 105. So 105, this one here. C5. This guy, poke that in. There we go. See if I can straighten it out a little bit. And there we go. Oh, go over here then. Okay, C5 was done. C6, 473. 473, this guy here, C6. Right here. Good. C7222. This guy here, 222. C7 is right there. Again, these are non-polarized, so it doesn't really matter which way they go, as long as they go in there. There we go. And C8101, which is this guy here. C8101. There we go. I flip this around and do the final soldering onto those. Looks like the solder has come through the through hole there, which is nice. Whoops, that did not go well. There we go. Just give it a little touch though. Clean the tip. Hard to get in there. I'll flip that around. There we go. Those capacitors are now soldered, and I can clip the leads. There we go, not too bad. This is actually going fairly quickly. Okay, I guess we should try to do the electrolytics. So C1 is 100 microfarad. Now this is easy, it is marked, and you can see here this bar should go towards the negative. Just going to make sure C1, the positive long foot, yep, that makes sense. See the bar here is negative. I never remember which side is negative on this though. I guess that's the negative here. Yes, the negative. The bar goes towards the hashed area. Hold that up tight and bend the leads. That's good. We might as well put the other two. Now the other two, they want them, actually I'll solder this one first, because the other two, this comes with a plastic case, and the other two need to be laying down in order for them to fit into the case. And I'm off screen here. Is that better? Yeah, that's better. 1, 2. There we go. It's good. I got a little bit of solder in this hole here. Just want to make sure that that's clear. Do I have anything to desolder? Yes, I do. Desoldering sucker is pretty good. Oops, did not work. There we go, got it. Okay, what is next? Still want to keep with lower profile components, so I guess these two capacitors, C3 and C4. C3 and C4, 10 microfarad, and positive long foot again. But yeah, these need to be laying down, so I might actually solder them from the front side. I'm going to bend it over like this. Sort of like that. Okay. I think this would work just fine. That's my multimeter complaining. I think this would work just fine if they were standing up straight if I didn't have a case for it, but the kit I bought, I specifically wanted the one with the case. Making sure, yeah, I soldered it correctly. This guy over here. I don't know if I should bend it. Yeah, I guess I'll try to bend it in between these two pins here. Hopefully that fits well. There we go. Those are done. Alright, so I guess now all that's left is the sockets, the headers. Okay, but I want to talk about the socket real quick, so let me get in a little bit closer and I'll show you the problem. This here is the socket that comes with the kit. I don't know if you can tell, but one of the legs were broken right off. So on this circuit board here, if you look, if I place it this way, the way it's supposed to go, see a little notch there lines up with a little notch on the silk screen, and that puts the leg, missing leg, down here. Now on this side here, you can see that that leg doesn't matter, but if I look on the bottom, it goes right over here. However, if you flip it over, it would be this leg here that's not connected to anything. You see that? And if I flip that around, it's not connected to anything here either. So I'm going to install the socket backwards in order to get it to work, and if it still doesn't work, I'll put a little jumper there. So let me put you back down on the table. Alright, so let's see if we get this working. So again, the notch is up here. I'm going to flip it upside down. See if this fits in there. I really should get a bunch of these sockets. I think that's going to be the next thing to be ordered in. Alright. Am I in shot? Yes, I'm in shot. Sort of. Okay, heat this corner. For sockets and ICs, I like to do opposite corners. I think that's the correct way to do it. It's not just what I like. I believe that's what most people do. And then here we go. Solder these guys in. Oops. Not too worried. When I saw that the socket was damaged, by the way, it's not the only thing in this kit that's damaged. We'll talk more about that a little bit later. I was kind of bummed, and I thought, oh, now I'd have to wait till I get a new socket. But then I thought, you know, if I can't get it to work, I'll just solder the chip right on. Really. Don't have too many qualms. My kits typically work even if I damage things. I can fix it. There we go. Should inspect my soldering up close. Yeah, it looks good to me. Perfectly fine. I just have to remember to put the chip in the socket the other way. The other thing that's damaged is this pin header here. I'll come closer. There we go. See that? The pin is coming right out of the plastic. So I'm going to have to solder it carefully. And hopefully it'll stay together. Oh boy. I don't know if it'll stay. Come on. It really doesn't help that I have big gorilla hands. That's from years of abusing my hands at work. If there's one thing I should have really paid attention to in trade school, is that your hand is not a hammer. Not wanting to take the couple of seconds it takes to walk back to your toolbox to get your hammer, you pay for it in the long run. I lost a lot of dexterity in my hands. Okay, I'll try to take this pin out. That one's out. I'll try to fit these 3 in and put the pin back in and hold it in with some sticky tack. Doesn't help that this pin is bent as well. I believe I just lost the leg on the floor. Oh no, here it is. I know you can't see it, but trust me, it's there. There we go. I had to grab a magnet. Alright, so I poke that in there. Just need to flip it so that the right way is facing around. There we go. Through the hole. Flip it around, and I should be able to solder it now. Whoops. There we go. And that should be just fine now. I just need to, I could just bend these things a little bit now that the solder's kind of cured. There we go. I should be able to use that as jumpers. Okay. A little bit more challenging. This, let's see, 10 bunch of pins. I think these are to set the frequency, at least the frequency range. So this should sit flat if I put it down like this, and it does. I'm going to try up here, quickly move in with the solder. There we go. Hopefully that was in shot. It was in shot. There we go. I definitely wish I had the skills that, like, let's say, Big Clive has with his soldering. But it seems to work for me, at least. At least I can get stuff done. There we go. Looks about right. Good. This is going fairly well. Okay, what's left? We've got this block here, a terminal block for here. We have this connector, and we have a couple of pots. So I guess it doesn't really matter which one we start with. We're kind of getting to the end here, which is great. I actually can't wait to see if this will work. Oh, there's a lot of mass in there. One, two, three. That's done. Whoops. Gonna jam those things onto the sticky tack. the socket in. There's a pin there. If you ever see like these sockets here, they have the pins on the side. If you put your sticky tack there, it might melt to it and be more difficult to remove. Still in shot, still in shot. Alright, this one's a ground plane, so that could take a little bit. I tend to press a bit harder to heat up the ground planes. Just better thermal contact. There we go, clean the tip off. This another ground plane here while the ground plane's still warm. None of that smoke is lead, even though this is lead-based solder. That is the rosin flux. There we go. Inspect my joints. I have a little bit of ball of solder here. It was a little cold. I think that's better there. That's good, but even the worst of soldering jobs will typically work for these not so critical applications. Oh, now I got to be careful because these are actually different pots. So this is R2, this is R7, and that's R8. So R2 is a B503. So R2 B503 looks like that. I'm going to put that one in there. I think I'll solder it from this side to get it started at least. Like that. This is R7. R7 is B503 again. 503. Are they all 503? No. 104 is the last one. So R7 and adjustable resistance R8 B104. Good. Okay, I'm going to tack down the legs here. See if I can get in there. It's kind of hard getting everything in the same spot. Try not to get these things too hot either. Ooh, that one's tight. And the last one here. Let's sneak it in by the corner here. There we go. The only thing that'll be difficult with these is getting the actual grounding posts here to solder, but we'll see. We'll see how that goes. That middle one must be the ground. It is sucking a lot of heat out. I have my iron set to 350 degrees Celsius. It is a fairly cheap 858 clone. So who knows how accurate it is. Could buy the soldering thermocouple to try to figure out the tip temperature, but then how do you vet the actual device that's measuring the temperature? Alright, let's see if I can get these body supports soldered. That is a large amount of solder necessary. If this thing works though, I'll be using it quite a bit. A few of you tried to guess what my secret device is that I've been hiding from you guys, and I feel like once this is built, I could probably shoot that video in the upcoming few days, because this does have to do with it. I don't remember seeing anybody on the comment section actually figure out what it was. That is the secret device. So if you guys want to keep trying to guess it, guess on this video, because after that it'll be fairly obvious once I reveal it. If you want some hints, it does have to do with this device. It is related with a function generator, so whatever it is, it's related. Oh yeah, those are nice and solid. I think that's it. I think that's it for the actual board and soldering. I'm just going to put what I did do before starting this is I took all the paper off the acrylic pieces for the case, so I wouldn't have to do that on camera. It takes forever. I hate doing it, but that's okay. Alright, let's open up the hardware bag. And I believe how it works is you have to put these little screws through here with these nuts, and this just secures it into, lifts it up off the board, I should say. And so you can drop this onto the acrylic without the components needing to be trimmed so much. So this doesn't actually need to be tight, it just needs to be not in the way. And I'm just going to trim these posts. They just went pinging right across the room. I think they give you 5 nuts, which doesn't make sense. No, I got 4 nuts. Okay, the photo online showed 5 nuts. And it didn't make much sense because there's only 4 holes for it. Another one there. Hopefully this works first try. They tell you you're supposed to test it, but I like to live dangerously. I'm just going to plug it in and hope it doesn't catch on fire. Okay, now you've got this backer board here, which these 4 screws kind of go in and hold it away from the bottom. And then you've got some side pieces. There's a side piece. There's a side piece. Then you've got these funky pieces here. So the narrow, see that narrow opening here? That narrow opening, I believe, goes facing up like this, so that the jack is accessible. Then you got this wider opening, and that one should go this way. Yeah, that lines up with that opening. And then you've got lettering here, like this, ground, square, sine, triangle. It should all slide together. And it does. And then you fit these little screws in. And there's no threads, there's just little serrated sort of hole at the bottom that these are supposed to dig into. At least I think so. I think that's the point. Can't really tell if it wants to go in there. You just squeeze this. Doesn't seem to want to go in there. I really don't want to break it. Oh, I think it grabbed. Yeah, that's grabbed. Oh, there's not many threads in there. I guess it's not really made to. It's not really made to be super secure. I wish they would have just went through a little bit and gave me nuts instead. I think I would have preferred that. But then again, I own a 3D printer, so I can design and print myself a case. And on top of that, I didn't buy this kit because it was the best. I bought it because it was the cheapest. So I guess I have myself to blame for this, right? They saved themselves 4 nuts like this. Okay, final thing. Let's see. Post points down here, and it points down here, so right up in the middle like this. That should be centered. And this says amp, fine, and coarse. This gives you your frequency measurements. I'm going to pop that right in the middle there. Right in the middle there. And right in the middle. Oh, if it lines up. Right in the middle there. There we go. 1, 2, and 3 pots. So they should go all the way down. Yep, there we go. So that's done. The physical build is done. The physical and the electrical build. I'm going to give these a little tweak tighter. And then I have to set myself up to test this, or else what kind of video would this be? Well, we have 2 problems with this kit. Both of which are my fault, really. One of which you guys very likely noticed for sure, and that is these went in way too fast. We are not even at that point in the build. Now, those of you who didn't notice, thank you, because I didn't notice either. But, you know, we all make mistakes, not a problem. The thing is with making videos is that if you're coming with me for the ride, you will see my successes and you will see my failures. My failure is fairly minor in one case. So first and foremost, yes, I forgot to put the chip in. It was not going to work without the chip. Remember, the notch is on the bottom side here, but it needs to go on the top here. The pins on this IC are like the only thing in this entire kit that were actually fine. They weren't bent from the get-go. If the socket is too narrow for the chip, just kind of roll the chip on your bench like this a little bit with even pressure. It'll tighten those pins in. So again, pin 1 goes up this way, like so. There we go. Okay, have you noticed the other problem though? I can almost guarantee you that you didn't. That's because it's hard to see. This is not a standard 2.5mm jack. This one is, and when I tried to put them together, it don't fit. So I want to use 2.5mm jacks. So what am I to do now? So I'm going to take this jack off completely. I'm going to use wire. I have this silicone wire here. I'm going to use just a length of wire, and we're going to do it that way for now. And we'll replace the jack with a proper one later. So I'm going to cut just, you know what, I'm going to give myself a good length here. So I'm going to cut this much, like that. Take this guy and cut the same amount from this one. This is actually much thicker wire than I need. This is 18 gauge, but I don't have anything smaller in silicone wire with two different colors. I only have the gray color, and I find that's a little bit thin even. Now the problem is these are plated through holes, so I'm not even sure if I'll be able to remove this. Just making sure here, yeah, that is definitely not a 2.5 millimeter jack, as much as I want to push it in. This might get ugly, folks, so yeah, hopefully I can get it off. I do have some desoldering braid, but I think I'm going to start taking the majority off with a solder sucker. Hopefully I don't lift any pads or cause any issues like that. Get this nice and hot. Got a bunch off, but not that much. The ground pad is so huge. I just wonder if I'd be better off just soldering to it. You know what? For the purpose of this video, I'm going to solder to it, and we'll just call it a success like that if it works. That's one. I'm going to take this one off here, like that. Hopefully I'll be able to squeeze this up and over. So I'm going to tin this wire here. Don't know why I'm using such big wire. I should really order some smaller stuff. I always balk at the price of thin wire. It almost seems too expensive to me. Okay, there we go. See if I can lay it sideways through here. See if I can. Don't know where my sticky tack went. Alright, well, here goes nothing. Let's do this in shot, shall we? So if I ruin this kit, I won't have to explain what I did. You'll be able to just see it. Ooh, that gets hot. There we go. That is hot. Okay, next one. See if I can twist it along like this so I can sit it like that. Pre-tin this. Come on, flow in there. Ooh, it's getting hot on my fingers. There we go. Just barely got it hot enough. Hopefully that works. If it doesn't work, well, oh well. I mean, at this point, what can I do? I'm gonna figure something else out. Oh, this guy got loose. Okay, I'm not sure how this side one's gonna work. It definitely doesn't fit like that. Well, that's a little upsetting. Can't really get it to fit. Well, you know what? Sometimes you just gotta do what you gotta do. That's the beauty of having a 3D printer. If I don't like the way something works, I just have to make my own. In this case, I may or I may not make my own. Alright, this guy, this guy, this guy, this guy, and then this guy. If I can fit that all down. There we go. Grab these screws. You know, was a little upset it wasn't the right barrel jack connector thing. But in a way I'm happy because whenever I'm looking for my barrel connectors, they're either stuck on another device or not the right size or whatever. I think I really like these bare wires better. Okay, thanks for hanging in through my incompetence. I'm going to put these on here. What do I smell? Burning plastic. It's probably not a good sign. Oh well, figure it out some other time. I'm going to stick these knobs back on. 1, 2, and 3. That's done. Peel back some of this insulation. This kit runs between 9 and 12 volts, so it'd be perfect for a 9-volt battery. But all my 9-volt battery holders have 2.5 millimeter jacks, and since they decided that that was not what they wanted to include with the kit, I've decided this is what I'm doing, bare wires. Alright, so let me set myself up. I'm going to zoom the camera out a bit, and we're going to power some stuff up and see if we can make it work. Alright, I really apologize for the different lighting here because, well, A, this battery doesn't have much juice. B, this screen is kind of crap. I've dimmed the lights and up the aperture size on the camera, so you should be able to see this now. Okay, it's not plugged into anything right now though. So here we go. We've got the 2 wires going out to my benchtop DC-DC converter. So 9.5 volts. It's 9 to 12 volt system. They say over 12 the wave doesn't, it becomes all crappy. I have this set to 1 to 10 hertz, so I assume if I have this at the lowest, then it's going to be at 1 and then probably move it up. Oh, sorry, that's the amplitude. Fine and coarse. So this one will probably be 1 to 10, and this will be just micro adjustments in between. Alright, so I'm going to give it power, voltage limit, which is good. We are only drawing 17 milliamps, so let's see if we can see something going on. Here I will set this to sine wave because triangle is kind of novel. I'm going to grab the square wave right here, and I will grab the ground right here. Okay, so what do we have right now? Absolutely nothing. I will up the amplitude. Still have nothing. Okay. I'm going to adjust this here. This is milliseconds. We'll go 2 seconds. This is drawing near nothing. I do not see anything going on on this. This is, oh, ground coupled. Let's go DC coupled. Still nothing. We're going to drop that to times 1. Oh. Nothing is happening here. Okay, let's try this again. This is still powered up. This is now powered by the same supply. It sucks. I really didn't want a switching supply to power this, but look, man, I have no other choice. And just to show you that it is in fact working, this is the test signal here. It should be 1 kilohertz. DC coupled. That's interesting. Why is that not working? It says running. Okay, so I think I have everything under control here now. Just to prove to you that this is now functioning, I can just put this on its own 1 kilohertz square wave test signal. Everything's good. Now let's see if we can get a signal out of the function gen. So 1 kilohertz is somewhere in here, 100 to, I've been going at this video for a while now. I kind of want it to end. So I will just try to get a 1 kilohertz square wave. So I got the negative hooked on here, and now I'm going to hook the positive lead of the DSO138 onto the square wave connector, a little piece of wire. Okay, this thing is going absolutely nuts. Let's see if we can fix this. This is the amplitude knob. It seems to be doing nothing. This is the fine adjustment. Can't tell. Yeah, fine adjustment seems to be doing nothing. Okay, so something's wrong here, but it's okay. I'm not sure what kind of signal comes out of here, so let's start adjusting parameters. So first of all, I see all the waves are all the way up there, and this is a super slow oscilloscope. I'm going to move the trigger all the way up here, see what happens. Okay, we're up in the 5 volts. We're triggering on something here. I don't know if I can adjust this down. Well, it seems seems to have done something. Okay, let's move this to, yeah, that's about it. Let's go AC coupled, see if it changes anything. Well, it moves that down there. I'm going to move the trigger down there. There should be a square wave, but I don't know if it's a AC square wave or a DC square wave. Yeah, it doesn't seem to be triggering. I'm going to move the whole waveform up a bit. It seems to be cleaning up. Not so much here. Oh. Back to DC coupling. Nope. This is 1 volt per division. So if I move this all the way down, see it's 1, 2, 3, 4.5 volts here. Moving the amplitude knob doesn't seem to be solving anything. Let's see if there's an issue with our timing. Let's move this here. Nope. Let's go faster. Switch it back to AC coupled. Nope. Okay. Well, let's slow it down a bit. Reset the oscilloscope. See if that helps at all. It seems to be giving us the same result. Multiplying the waveform doesn't seem to be helping. Right now we're getting a flat line. I'm going to swap back to the pointer. Move the pointer up. Still an AC coupled. Oh, we got... Is this something significant? I don't think so. I'm not sure what to expect here. Oh. What's going on there? The negative, like 9 volts. And the positive, let's see if we can trigger. Single shot, no, automatic. Trigger on the rising slope. Can't get this thing to trigger at all. Let's see if we can do a sine wave reading. DC couple or AC couple that. I'm not sure if this is even functioning. I don't know if this function generator is actually functioning. Well, I guess the next point is to pause. I'll have a poke around and see what I can find. Well, it's been nearly a week since I put this thing together, and I actually got it working the same day, but I was so discouraged from missing so many things that yeah, I didn't finish the video. This has literally just been sitting on my bench for like a week or so, whatever it was. So let me now just zoom you in closer, and I want to show you what was wrong with this. So I hope I'm in focus here, but you'll see that some of these solder points are not perfect. Some of them are a little bit lacking on solder. Some of them have a bit too much, like that guy here has way too much. This is the pin that's missing, so if you see a hole there, that's why. But I had forgotten to solder, I think it was all of these. And if you guys were watching on the video, you probably noticed it, but I'm a good, I don't know, 1.5 feet, almost 2 feet off my bench when I do these kits, so I couldn't actually see it. Also, you'll see that right here, this is not soldered very well, but it is soldered and holding. Some of these have too little solder on, but it's not too bad because that's just the case of the rotary encoders. But anyways, I will now demonstrate what it looks like on this DSO138. But now that I got the chance to take a look at this, I would say the DSO138 is actually not that useful for this kit, and I'll show you why. Okay, if I got the focus wrong, sorry about that, but this is low light, so it's very hard to focus in. But here we go. So I have the function gen here connected to the same power supply as I have my oscilloscope here, DSO138 connected. I'll just go ahead and hit the test signal. There we go. That's the test signal on the DSO138 by itself. We're at half a millisecond per division here. Okay, and it's 1 volt per division, which is as low as it goes on the DSO138. You can't actually go any, you can't have like more volts per division than that. I guess we can, yeah, you can actually multiply it times 2 times 5, so you can actually go up to 5 volts per division. Sorry, that's the max. We'll go 2 volts here. So there we go. There's the test waveform, and let's check out our function gen. Now I have the jumper in the third from the top, so between 100 and 3 kilohertz. So I'm going to connect up the ground first over here. And I'm going to connect up the square wave, and I'm just going to adjust the trigger. I'm going to trigger a bit lower. Boom. There's our square wave. So this is the coarse adjustment. Let me just move this up a little bit. The coarse adjustment is this one here, so you can see you have a much bigger impact on the waveform here. This is our fine adjustment, so you can adjust it, but not as much. Can't get it nearly as far as the coarse. There we go. We can stretch that down quite a bit. And then this is the amplitude adjustment, which doesn't seem to make too much difference on the square wave, but it looks like our square wave is 2, 4, 6, 8, probably about 7.5 volts or so. But yeah, this is not too bad. So it does work. It does output a square wave. Let's check on the, I have it set on triangle wave right now. So it's this other input there. Okay, again, I gotta adjust the trigger. I'm gonna trigger it down. I'll center the waveform a little bit better so you can see it. So there it goes. Okay, so for the triangle waveform, the amplitude will actually smooth out the spikes. So I'm just going to drop this down a little bit. There we go. Okay, so it's triggering in the middle here. And if you look, I crank up the amplitude and it becomes more of a sawtooth. I crank down the amplitude and it heads more towards a square wave. So I think that's what that's supposed to do. I'm not sure. If I swap it into sine wave, there we go. We have almost a perfect sine wave here. So it's actually pretty nice. It does work. That's fantastic. So let me put this back together and I'll show you one last time. And there we go, all reassembled and ready to go. Now let's see how high we can actually push the DSO 138. I think we're going to start losing the plot a little higher up. So here we go. So this is between 3K and 65K hertz. Let's see if we can actually trigger that a little bit quicker. You see here already at about in the middle of the range there. You see how the corners get clipped? That's not a square wave. So this thing is starting to already lose the plot. It's not very fast. I'm going to go up to its full speed. I don't think we'll be able to trigger on this, but let's see. Now you see? See how it rounded the corners completely? It's not a very quick scope. Let's see if we can actually get that, in fact, down to a speed where it'll trigger. Sorta. But you see it's basically a triangle wave now, even though we're on the square wave setting. So yeah, it's not particularly fast. Here we go with a much, this is the lowest of the range, 1 to 10 hertz, I think. So let's drop this down. It's not even catching that. The sample memory is too short. Or is that it there? Yeah, it is grabbing it there. No, sorta. See that the memory is too short, so it actually gets tripped up. Doesn't have enough onboard memory. See, I adjusted it, and now we have to wait. It sort of works to get you unstuck, but it's not fantastic. But anyways, that's the end of this kit build. It's been a huge one for me because I've never messed up so much on a kit build before. But I figured I'd show you guys anyways because at the very least it keeps me humble, shows you that I'm just human, shows me that I'm just human, and I'll see you in the next one. By the way, has anybody figured out what the top secret tool is that's coming up? leave it in the comments below. Thanks for watching.